Hi guys, this is Miss Elkins. I wanted just to do a little bit of quick lesson about area and perimeter dilations because that seems to be the thing that's tripping some people up. So I want to look at this area and dilation of these two rectangles that have been dilated by a scale factor of 3. So you can see that the original rectangle is the smaller one, A, B, C, D. And of course the larger triangle, a rectangle, A prime, B prime, C prime, D prime is the enlargement or the dilation. So the original rectangle has a length of 4 and a width of 3. And when you multiply both of those numbers by 3, the scale factor, you get a length of 12 and a width of 9 for the new rectangle. And let's talk about what happens there to their area and their perimeter. Well, the perimeter of the original is 14. When you add 4 plus 4 plus 3 plus 3, you get 14. The perimeter of the dilation, the new figure, is 42. So that's just adding up 12 plus 12 plus 9 plus 9 to get the perimeter. And then the area of the original figure is 3 times 4, which is 12. The area of the dilation is 9 times 12, which is 108. So you can see that number is a lot bigger. We'll talk about why. When you dilate a figure, the perimeter of the image is equal to the perimeter of the pre-image, the original, times the scale factor. So the scale factor stays the scale factor. So if you have a new figure, we'll call it P1, it's always going to be equal to the original figure, P, times the scale factor. And I'm going to start abbreviating scale factor, which is SF. So now you know that's what that means. So in this case, in this case, the perimeter of the new figure is 42. And that's equal to the perimeter of the old figure, 14, times the scale factor, which was 3. So the scale factor increases the perimeter by the same number. It doesn't happen with the area, though. Let's see. The area of the new figure is going to be equal to the area of the old figure times the scale factor squared. You see it's a much bigger number. 12 and 8 are quite a few clicks away from each other. So you can see that perimeter, or the area of the new figure, is 108, which is equal to the perimeter of the original figure times the scale factor, which is 3 squared, or 12 times 9. So the scale factor moves up by an exponential factor with area. So if you can just remember this right here, area will be the scale factor squared, no matter if it's a small number or a large number. Okay, let's put that into play with an example. Here we go. Example, a triangle has a perimeter of 30 centimeters and an area of 37.5 centimeters. The triangle is dilated by a scale with a scale factor of 2.8. What is the perimeter and area of the triangle after the dilation? So we'll use what we just learned. The perimeter of the new figure will be equal to the perimeter of the old figure times its scale factor. So the perimeter of the new figure will be equal to 30 times the scale factor, 2.8. So the perimeter of the new figure will be 84 centimeters. Easy, very straightforward, just multiply by the scale factor. Area is going to be a little different. The area of the new figure, remember, is going to be equal to the area of the original times the scale factor squared. So the area of the new figure will be 37.5, that's the old area, 37.5, times the scale factor, 2.8, squared. Now, if your calculator doesn't have an exponent button, here's what you do. Multiply 3.75 by 2.8 by 2.8 again. That's all you're doing when you're squaring a number anyway. So, the new area of this figure after being dilated by a scale factor of 2.8 will be 294 square centimeters. There. I hope this helped. Hope you're having a good day. Hope I see you soon. Have a good day.